Hi dear students, today we discuss the measurement of high resistance by leakage. In the last class, we discussed the decay of charge through a resistor. That is, we had a resistance and a capacitor was connected to a battery source, then a key. When the key is closed, the circuit is closed and the maximum current flows through the circuit, and the capacitor was charged into Q0, that is its maximum value of the charge. Then when the key was just opened, then the capacitor starts to discharge, and to discharge through this resistor, and the discharging of the capacitor through the resistor, or the decay of charge through a resistor, that was given by this expression. Q is equal to Q0 into e power minus t by tau, where tau is the time constant RC. We have explained everything in the last lecture. Then this Q can be written as Q0 into e power minus t by RC. This is nothing but the decay of the charge through a resistor. Then we will use this expression to find the value of the resistance by the leakage method. That is, if I rearrange the term, I can write this as a Q by Q0 is equal to e power minus t by RC. And if I take the reverse, Q0 by Q, this minus sign will goes to positive, it is t by RC. If I take the natural log, this will be natural log Q0 by Q, then right hand side will be t by RC. We are interested to calculate the resistance of an unknown resistor by the discharging method. Shortly we will say this is a leakage method. Fine. Our interest is to find out the expression for the R. That is that from this we can write resistance R can be written as T by capacitance C into natural log Q0 divided by Q, where Q is the value of the charge at any instant of time and Q0 is the maximum charge on the capacitor when it is fully charged. That is, the time t is equal to 0, the maximum charge on the capacitor is Q0. If I write this into normal log, that is, this R can be written as T divided by this, I can write 2.303 log Q0 by Q. Therefore, this will be 2.303 C log Q0 by. Okay, this is the expression that we will use to find out the value of the unknown resistance R in the experimental method. That is, here we will calculate this Q0 by Q, this time from the experiment, and then the R can be calculated, because the value of C that we will use in the experiment is already a known factor. This is a known value. Note, if you determine Q0 by Q from experiment, then R can be calculated. Then what is the experimental setup to measure this unknown resistance? That is our next task. This is experimental setup that will be used to calculate the value of Q0 by Q, and this circuit consists of a capacitor C, resistor R. Here we will use three keys. The first key is the K1, K3, and this is K2. Okay, I will write this key even here. Fine. Now, this is a ballistic galvanometer. BG is nothing but ballistic galvanometer. I request the viewers first to watch the working of ballistic galvanometer. I have given a link of this video, that is the working of the ballistic galvanometer, in the description box. Here I will not explain the working of the ballistic galvanometer because it will take much time, then the video will be lengthy. Fine. Another component in the circuit is a battery source E. Now, our unknown resistor, that is the value of the unknown resistance, that is connected here in the circuit. Let us proceed how to calculate the Q0 by Q from the experiment. Then after getting this value, we can substitute this expression and we can easily find out the value of the resistance. The value of the C, that is a known factor because we know how much value of capacitor is used in this experiment. Fine. Now let us go to the procedure how to find out the Q0 by Q. Title of this discussion, that is the measurement of fire resistance by leakage. That is, this leakage means it's the decaying of charge through the ballistic galvanometer and also through the resistor. Okay, that is the discharging of the capacitor through the resistor and the ballistic galvanometer. Okay. That is why the leakage term we used. In this arrangement, we have the three keys. That is, the first key is K1, and K2 is connected here, K3 is connected here. Okay. First procedure, that is, first we will open the key K2 and K3. They are already opened, and we close the key K1. That is, we close this key. Then a current that is flowing, that starts to flow from this battery to this way. Since this path is open, no current will flow through the circuit, and again go like this. And here also the path is open, that is, here key 2 is open, the circuit is open, no current will flow through this one, and the current will further grow. This will form a complete circuit. That is, the current will flow in this direction. Okay. That is, the capacitor charges to maximum value Q0. That is, we will write here, open the key K2 and K3 and close key K1. What will happen? The capacitor charges to Q0. Fine. Now our capacitor is fully charged. Then the second step, open the key K1. That is, this key we have to open. This is opened, and close the key K3. We have to close this key. Closed. And keep the key K2 was opened. Now what will happen? The capacitor is already fully charged in the first step, and now the capacitor discharges through this ballistic galvanometer. The ballistic galvanometer is a device that is used to measure the value of the current, or that you will detect the presence of the current in the circuit. That is, the ballistic galvanometer produces a throw. Throw means a deflection. That is theta. That is theta will be proportional to the value of the current I that is flowing through the circuit. Okay. You get to know the more information about ballistic galvanometer. I request you to go through the link that I have given in the description box. Fine. Simply we can understand ballistic galvanometer is a device that is used to detect the presence of the current in the circuit. The total charge on the capacitor is Q0, and this charge starts to flow through this BG. There is a flow of the charge produces a current, and according to that current, a throw, there is a deflection theta will be recorded in the BG. If Q0 is a total charge flowing through the circuit or through the BG, then let us note down theta 0 is the corresponding throw in the ballistic galvanometer. അതായത് നമ്മുടെ കപ്പാസിറ്റർ ഫുള്ളി ചാർജ്ഡ് ആയിരുന്നു. ഇവിടെ കീ K1 ഓപ്പൺ ചെയ്തു, K2 ഓപ്പൺ ചെയ്തു. ഇപ്പോൾ ക്ലോസ്ഡ് ആയിട്ടുള്ള ഒരു പാത്ത് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ശരിക്കും ഈ ഒരു പാത്താണ്. അപ്പോൾ ചാർജ് ഫ്ലോ ചെയ്യുന്നത് ഈ ഒരു പാത്തിലൂടെ നമ്മുടെ ചാർജ് ഫ്ലോ ചെയ്യും. ഈ ചാർജിന് ആനുപാതികമായിട്ടുള്ള ഒരു ഡിഫ്ലക്ഷൻ, ഒരു ത്രോ നമ്മുടെ ഗാൽവനോമീറ്ററിൽ റെക്കോർഡ് ചെയ്യും. മറ്റുള്ള രണ്ട് പാത്തിലൂടെയും കറണ്ട് ഫ്ലോ ചെയ്യില്ല, അല്ലെങ്കിൽ ചാർജ് ഫ്ലോ ചെയ്യില്ല. കാരണം ആ രണ്ട് പാത്തും സർക്യൂട്ട് ഓപ്പൺ ആണ്. Therefore, we can note down the steps. Is open K1 and close K3. Now capacitor discharges through the galvanometer through the ballistic galvanometer, which records a throw. That throw is denoted by theta 0. Be careful, this is not Q0, this is a theta deflection. We denote it as a theta 0. Therefore, I can write the charge flowing through this galvanometer and producing a deflection theta 0. We can write this, the Q0 charge, this is Q0, that Q0 charge produces a deflection theta 0. Therefore, I can write this is a Q0 is proportional to theta 0. Fine. Now, let's just go to the third procedure. Now, in the steps 2, the charge on the capacitor was slightly reduced because the capacitor discharged through BG. A few amount of charge might have reduced from the capacitor. Then again we have to charge this capacitor. Then again to charge the capacitor, the battery should come into the picture. Therefore, to charge the capacitor into the Q0 value, we have to open the key K2 because already it is open, and K3 also. Okay, it is opened, and we have to close the key K1. This is closed. Now this path, the resistor and BG are not in the circuit because the circuit is open. Those two circuits are open. Those two paths are open, and the voltage is now in the circuit. Therefore, the capacitor again charges to its maximum value, Q0. Fine. Let me note down. Again, charge the capacitor to maximum value, Q0. For this, what do we have to do? We have to open key K2 and also K3 and close K1. Fine. Next, what we will do? In the third step, the capacitor was fully charged because K1 was closed. Now we have to discharge this capacitor through this resistor. For this, we have to open the key K1. K1 is opened, and we have to close the key K2. Fine. Then key 3 keep opened. Then this key K2 is pressed or closed for a known value of the time, for a small amount of time. Then some of the charges in the capacitor leaks through this resistor R. This charge will flow through this path, through the resistor. Fine. Let us say some of the charge leaks through the resistor R. Open K1 and close K2 for a known time. See, some of the charge now leaks through the resistor R. Next step, that is the fifth one. Few amount of charge now passed through this resistor, and few charges may be remaining there in the capacitor. Then now we will allow the remaining charge to discharge through the ballistic galvanometer. Fine. For this, we have to open the key K2. Therefore, no charge flow through the resistor, and we have to close the key K3. Therefore, the remaining charge on the capacitor will discharge through the ballistic galvanometer. With that remaining charge is the Q, because Q is a value of the charge at an instant of time. That produces a current flow through the ballistic galvanometer. That current flow causes a throw in the ballistic galvanometer. That throw is proportional to theta. Fine. That is in the fifth step, the key K2 must be opened and the K3 closed, K1 as it is opened. It is open K2 and close K3 at once. അതായത് നമ്മൾ ചെയ്യേണ്ടത് കീ K2 ഓപ്പൺ ആക്കിയിട്ട് K3 പ്രസ് ചെയ്യുക. ജസ്റ്റ് ഒന്ന് പ്രസ് ചെയ്താൽ മതി. കീ K3 ജസ്റ്റ് പ്രസ് ചെയ്തങ്ങ് വിട്ടാൽ മതി. കുറേ നേരം നമ്മൾ K3 പ്രസ് ചെയ്ത് നിൽക്കേണ്ട ആവശ്യമില്ല. K3 ജസ്റ്റ് അങ്ങ് പ്രസ് ചെയ്തിട്ട് അങ്ങ് വിട്ട് കഴിഞ്ഞാൽ ആ ഒരു ടൈമിൽ ഇതിൽ കൂടി ഫ്ലോ ചെയ്യുന്ന ബാക്കിയുള്ള ചാർജിൻ്റെ എമൗണ്ട് ദാറ്റ് ഈസ് പ്രൊപ്പോർഷണൽ ടു ദ തീറ്റ. നമ്മുടെ ബാലിസ്റ്റിക് ഗാൽവാമീറ്റർ ആ ചാർജിന് ആനുപാതികമായിട്ടുള്ള ഒരു ഡിഫ്ലക്ഷൻ കാണിക്കും. ആ ഡിഫ്ലക്ഷനാണ് തീറ്റ. Therefore we can say the charge Q remaining on the capacitor, then discharges through the galvanometer. Okay, then that discharge produces a throw, that is the resulting throw, theta is noted. That charge Q is proportional to that theta. Fine. Our aim was to calculate this value of the unknown resistance R that is connected in the circuit. To calculate that unknown resistance, we know the known parameter is time, because the time that we have mentioned here in the fourth steps, that is open the key K1 and close key K2 for a known time t. Okay, this was done for a certain time t. Therefore that t is known. The value of the capacitance used in the circuit, that is also known. Only the unknown factor in the circuit in the equation was Q0 by Q. To find out that Q0 by Q, we are performing this operation, that is this experiment. And how we can find this Q0 by Q? If you look at this steps 2, that is where we have found the maximum value on the maximum charge Q0 is proportional to the theta 0. And from the fifth step, we obtain the value of the charge that at any instant of time Q is proportional to the theta. Therefore, from step 2 and 5, I can divide those two equations, that is Q0 by Q is equal to theta 0 divided by, be careful, this is Q0, this is Q, theta 0 divided by theta. Instead of Q0 by Q, now you can substitute this theta 0 by theta in the first equation. That is the value of R, unknown resistance, can be calculated using the equation 1. That is, the equation 1 was, actually I have not put an equation number, this is equation number 1. That is, now instead of this Q0 by Q, now we will substitute theta 0 by theta that we obtained from the ballistic galvanometer. Therefore, this can be written as T by 2.303 C log theta 0 by theta. This is the, in this way, one can find out the value of the high resistance using the leakage method. We have to plot the graph. From the graph only, we can calculate this value of the R accurately. That is, for a series values of t and theta, we can plot a graph between the time on the y-axis and log theta 0 by theta on the x-axis. That is, let me note down here a series values of t and theta are obtained from the experiment then plot a graph between time t and log theta 0 by theta. Okay, actually if you write this expression, this is the expression for the r, this will give you a straight line. That is, the graph of t versus log theta 0 by theta, that gives a straight line. Therefore I can write here this graph is a straight line. We plot on x-axis log theta 0 by theta, and on y-axis this will be time and its graph will be a straight line. Therefore the slope of this graph give a mean value of t by log theta 0 by theta. The slope gives the mean value of t by log theta 0 by theta. Is as value of the capacitance C is known, then the value of R can be calculated. Okay, this is the way of measuring the value of the high resistance using the leakage method. Okay, thank you very much.